So the original structure of programming languages, anybody remember? We talked a tiny bit about it, like GW Basic, and even actually, for that matter, Fortran and
You said that you'd have to like point one piece of code to another piece of code, and it would become really messy.
it would get, yeah, it was basically, it was just top down.
Yeah.
You started at line one and then you kept going, right? And if you wanted to reuse code, you had to, basically, you had to say go to. Go to is like an evil word in programming. So the lines typically had numbers. If they didn't have a number, what you'd do is you'd create like a little stopping point, like I mean, literally, you just give a variable name like stop, and then down there you'd say go to, and you'd have to find stop. Or you could give it the line number, go to line number. The trouble is that so you go to that line number. When you're done with that, then you'd have to test. All right, so if you came from this line number, go down here. If you came from this line number, go down here. It just made the code unreadable. So all of this stuff is about complexity. The very first programs, if you're only writing a 30, 40 line program, top to bottom works just fine. In fact, it's probably the most efficient way to do it, but as it got more complex, and as more programs happened and people wanted to reuse some of their code, it became really insufficient, right? So it was difficult to read, difficult to debug. And not very reusable. So that's basically just moving to top. So the next thing, and Python is still kind of in this method. There's been a kind of a return to it lately, but this is the structured programming. And this is where you break things up into functions or methods. So methods technically are functions in classes. Not that that matters a whole lot. So when you break it up into functions, and the modern term for this, and you might have heard it, is called functional programming languages. Have you guys heard that term?
Yes.
So there's a few functional programming languages. Python is essentially one. Microsoft did F#, F for functional.
Yeah.
The idea, basically, you're just breaking things into functions. These work really well with certain kinds of problems, like statistics analysis, right? So Python is good for that. F# is basically a language for engineering and math. R is another language that does basically that kind of thing. You just break it into functions. The initial advantage of breaking things into functions when they first did it, anybody remember Pascal?
Loosely.
Yeah, that was sort of the test language, the academic test language for this kind of programming structure. It allowed you to break things up. Each function did ideally one thing. I mean, it could have a lot of code in it, but the point of it was one thing. It did one activity. The advantage of that is that if you needed to reuse code, you could just call that function, right? You could call it from anywhere. That was part of the thing. So you could call that function whenever you needed it. So it allowed you to reuse that functionality without having to do a go-to or create some kind of copy and paste, which is another strategy for reusing code. And it works really well. But again, there's a point of where it breaks down. And that's usually when things get really complex and as computers get more and more complex. These things happen. So imagine like Windows, you were programming Windows and you wanted to do it functionally. You would have probably thousands, maybe even tens of thousands of functions, right? Windows has hundreds or thousands of classes. If you had you know, if you had it as just functions, you'd have literally just innumerable functions, thousands and thousands of them. The trouble is it starts to get hard to manage that many functions, right? It's really hard to keep track of them. It's hard to make sure that they all have unique names, especially when you have a small army of programmers working on the same project, right? So keeping all that consistent and stuff, it becomes really difficult. Does that make sense? So all of these things, each of these new strategies evolves out of added complexity as you go on. Also, one thing to know is that in a certain sense, none of these are ever abandoned. They just get incorporated into the new model. Even the top down, I mean, basically the whole algorithmic structure of programming, these things have to occur in a certain order, right? So each of your commands has to be in the right sequence or it won't happen. So the top down is still there. Even in object-oriented programming, which is the next big thing, functions, you still want to break your code into functions, and each function should do one thing. It's just that now they are further encapsulated into objects. So object-oriented programming is an attempt to handle greater complexity by grouping the functions into objects that are sort of natural to the process. Does that make any sense?
So functions exist within the objects.
Yes, they do.
Objects are basically a collection of methods.
They're collections of methods and properties. So properties are things that describe the object. So if you had think of a point of sale. If you want, what are some of the natural objects in there? Yeah.
So where you're at, it's almost kind of like a code palette or a family of things, whereas it's red, but really red could be pink, could be,
Yeah.
And so you're almost doing like a family of things. It's almost like when you're doing, it's like a database structure in a sense.
In a sense, although actually one of the huge complaints of programmers is that database structure doesn't map well to objects. They do in a way.
Right.
I mean, your point is actually fairly good, but a database split things up more than objects do. So grouping, I'm just going to say real quickly, grouping the functions into related objects. Again, if I was going to say like a point of sale, you might think that there's a sale itself, right? That could be an object where all the things that actually process the sale. And then there might be something like if you're keeping track of the customer, you might have a customer object, right, that contains the information about the customer in the sale. You probably have something, I usually just call it item, the thing being sold. And again, each of these things is a package of information and sometimes methods. Objects don't always have to have methods, and they don't always have to have descriptions. It could just be methods. It could be just descriptions, or they could be both. But the idea is you break these things up. You might also have, and this is where it gets closer to the database probably, it might have an inventory item. You might have not only the item, but the, in websites they call it the something bag, the
Shopping cart.
the what?
Shopping cart?
Shopping cart, that's what I was looking for. And what the shopping cart practically is a list containing items, right? So the thing is, by breaking it up into things that actually sort of describe what's going on there, you can look, so any method related to processing the sale should be in the sale object. Any method, anything related to the customer should be, I mean, that the customer can do is in the customer object. It allows you to further group these things, and ideally, if you actually read object-oriented code, it rarely happens this way, but ideally break it into objects that make sense given the functionality of what you're working with. Does that make sense, what I said?
Divide the objects into ways that make sense based on what the program is supposed to do.
Right. So if you're doing, I mean, this gets really as I said, it can get really complex. There are books on object-oriented theory that read like philosophy books, in terms of what makes a good object. How do you layer the objects? Because one of the next things that you do is you create layers of objects. So there's usually a data layer that talks to like the database or talks to file systems. And then there's a business layer that does all of the analysis of the data that comes either in from the data or comes in through the forms, which is the display layer. So there's a three layer that's really obvious. There's a display, business, and data. I mean, so they start breaking things up even more there. And there could be sub layers in that. It can get fairly complex. I'm going to talk in a minute about what constitutes an object, because there's a complicated, I'm not going to actually test you on any of this, but I think you should hear it at least once. And then as you move on, hopefully you'll play with objects more. There's another newer thing that actually, again, it incorporates all of these, including the objects. And we're not going to do this, but I just wanted to mention it. And you can do it with Python too. Any of you have ever heard of SOA? What's that stand for again? Service-oriented architecture. Arc, I can't spell. Why can't I spell? What?
It is with an H.
Yes.
Yeah, arc. That looks wrong, but I believe you. Service-oriented architecture incorporates objects, but the objects are divided up into services. And the services, so actually Windows is structured this way, and a lot of websites are structured this way these days. You write a service, and the service does like one complicated thing, usually not a simple thing. The service in itself, in its own body, will have several classes, right? So several objects are in the body. But the service is basically what you do, like with Windows, what you do is if you want to access the file system, it calls a file system service, right? These services are running in the background. The nice thing about the service-oriented architecture is that you can swap them in and out without necessarily affecting the overall structure of what's going on. So you can update pieces, and that's part of it. It's part of the sysop kind of thing where you're constantly, the new philosophy, and it drives me nuts, really, is constant updates. Used to be you would go through update cycles, right? So you would update Windows or Visual Studio or something, you would update it once a year, or once every other year, right? In SQL Server, they tended to be about every 2 years they would do an update.
Then a month.
Then it's a month, and now it's constant. It is literally constant updates. And the way you can do that, the only way you can do that, you can't sit down and rewrite the whole program every time and go through and change it. What you do is that programs have become bundles of services, and what you can do is you can add services. So you can add functionality by adding a service. You can add functionality by changing the service. And it doesn't break the old one because the new version can incorporate the new features in the service, and the old version just uses what it knows in the service, right? So you don't have to break the service. You can constantly, I mean, literally you can put out updates because you don't have to redo the whole, you don't have to revisit the whole program. You revisit the individual services. And each service does like one big thing. Websites are like this too now. A lot of websites are just calling services. You might call a service, say you're a travel thing. So you pay to have access to a service from the different airlines so that they can post, you can get their airline thing. Hotels will publish services that give you the what room availabilities they have. There are all these different services, and typically they cost money. So you bundle them together, and they can change the services. There's no display on a service. You write your own displays, right? So it's an interesting. We're not going to do anything with it except to say that it exists. But it also incorporates objects. You see these services as object-oriented in its structure. So none of this stuff goes away, and each object has a structured methods. I will look for my PowerPoints and post them just so you can get a more visual sense of this too. Okay. So let's talk a little bit about what makes an object. And they usually say there's four terms, and this is where the philosophy almost gets in, for objects. Anybody know what any of them are off the top of my head? I'm just curious. I'm not expecting.
Class?
Well, so class is just an object that isn't being used.
Okay.
Technically, the distinction between a class and an object is that the class is the description of the object in code. Object is when it's actually being initiated and used.
Okay.
Right. So classes, they're the same thing. It's just different states. Encapsulation is the first. What would you guess that means, if anything?
There's like I guess the best way I can think about it is like, there's like a container that you put things in.
So it is a container, and there's a couple of aspects of this container. It should be self-contained. Insofar as possible, it should have no dependencies, right? One of the ideals of object-oriented programming is like Legos. Basically each is a block, and you just put the blocks together however you want for what you're doing, get the result. Another maybe method of it is if you ever put together a computer,
yeah.
It's all the circuit boards that can only go into one slot. It's all components. You just choose the right components, put them in there, and plug them up, plug them together. That's sort of the ideal. They would like your programming objects to be. So anytime you had a customer in your program, ideally you could plug in that object and never have to look at it, just assign values to it. In real life, that doesn't happen so much, but that's the theory. The other part, so it should be self-contained insofar as possible, and it should be complete insofar as possible. It should contain all that it needs, right? Again, it's both of the ideas is that it shouldn't have external dependencies. It should be a complete description, say, of a sale or a customer, and it should be as self-contained as possible. Yeah.
Is this simply assuming that we're avoiding it needing to plug into other things as much as possible?
Right. Well, so it should do, like, if there's a calculation that although it also should only be about itself. Does that make sense? An object should not be customer and sale together, right? Each thing should be about one thing, but it should be a complete description of that thing. And it shouldn't have to call another class to complete an action that's relevant to it. Now, you can pass it to another thing where it can be processed. Right? They do talk to each other. There's relationships between classes. But ideally, you could take the customer class out and replace it with a new customer class, and nothing else around it would have to be changed. Yeah, a dependency would be like if you pull this one out, then you've also got to pull this one out and also got to pull this one out and make changes to all of those. Does that make sense? Again, it's an ideal that's not always met in practice. But and as I said, you'll get into, in books if you really care, and you probably may never care, but there's books that argue about what makes encapsulation versus what doesn't. Because one of the next big things, a lot of people argue that this violates encapsulation. And yet it's a very big thing in object-oriented programming. So inheritance is for code reuse. And it's basically that one class can inherit from another, and you don't have to reproduce the code that is in the parent class, right? It's the child automatically gets that. And it's almost always, so you get a child class that basically gets everything in the parent class. Okay, and it always moves from the more general to the more specific. So you might create a class called person, and then it could inherit from it could be like customer, employee, you know, that kind of thing. So these are more specific. This is more general. The reason you would do that is that all employees and customers have certain things in common. So they all have a name, they all have an address, you know, they all have maybe an email thing. Whatever is common to all of them, you put in person. Whatever is specific to customer, you put in customer. Whatever is specific to employee, you put in employee. So the idea is to move from more abstract to more particular. And there are, despite the fact that it kind of creates a relationship, that dependency, right? If it's done right, you know, it keeps code repetition down a lot. But you have to think about it when you do it. I mean, it's weirdly, most programming languages, and Python is included, have a general class called object that all objects inherit from automatically. The advantage of this too, and I don't want to get into all of this because we're not going to go into that deep when we actually do it, but one of the things is if you have a class down the line and you don't know if you're going to be talking about a customer or an employee, you can just say person. You can always substitute a child for the parent. It gives you a lot of flexibility. You can't substitute a parent for a child, by the way, but you can always substitute because the child has all of the parent and more. So you can always substitute the child for the parent. Does that make sense?
So it's kind of like you can always be more general and then go more
Right,
specific.
right. And one of the principles, so we've got inheritance and encapsulation. One of the major principles is abstraction too. All right. And there's a couple of ways that this is. You should always write, if you're doing a customer, it should be a general customer, not Joe, right? You don't write a class for Joe, you write a class for a general customer. But it's more than that. Part of it is the idea of abstraction is you keep abstracting out everything that's common. So you create an abstract class called person. You might create a person class that you can never actually use, but you have all sorts of different kinds of people inherit from it. But you created the person class so that everything that was common is abstracted out. So abstraction, again, it's one of those things that can, on the basic level, it means that you write for a generic customer. You write for a generic sale. You don't write for a particular, if you're writing for a particular company, you don't want necessarily to create a sale that's totally specific to how they do it. You'd want it to be generic enough that you could adapt it to everything, every other person that has every other point of sale system, right? Again, this is the ideal, not necessarily always the practice. The idea is that everything should be general, everything should be adaptable, everything should be reusable. Okay, it doesn't always happen. So encapsulation, inheritance, and then there's a fourth term, which you probably don't know. I'm just putting a star by the terms. So I said I might post this, but I'll also post I have some I think the trouble with my PowerPoints is they all use C# for examples. Anybody have any guess what the next term is? The last term? It's Greek. That helps.
Nope.
Polymorphism.
That's not right.
Anybody have any guess what that would mean? Poly means many, morph means form.
You can use it in many different ways.
Right,
Right,
and it will change how it functions depending on the context. So,
Is a good example of like, hey, if I'm
like what?
meeting with the president, you know, when formal dressed up, what we'll do, come out in the stick somewhere, you know, I'll prepare, have my cowboy hat and pocket.
To some extent, that's
I'm
an.
say hello, but it's a different.
That's actually probably not a bad one. I hadn't thought of it in that terms. In coding terms, what it really means is that, for instance, you might say, you might pass it an int and it'll behave one way. You might pass it a float and it'll behave a little bit differently. It also means things like when you think of a button that you put on a form, a button is an object. What that button does when you click it is very variable, right? It changes its behavior depending on
what you
yeah.
have told it to do or expect.
Technically, it's usually represented in two ways. And again, a lot of this is just, it's usually represented as overriding and overloading of functions. Anybody know what overriding is? Overriding relates directly to inheritance. Yeah.
Well, the inherited, or the object that inherited the parent might change something of the parent to fit its own need.
Right. It might take one of the functions, like the parent might just return, oh, if it was person, maybe it just returns the person name or something. You might change the employee thing so that it returns not the employee name, but the employee number. And it might have the same name. The function might have exactly the same name. In fact, it would have exactly the same name. Does that make sense? So the function in one of the examples they often use in books, they even use it in here, it's like an animal. So you have a class called animal, and then you inherit dog or cat. The animal makes a sound. The cat meows, you know, but this function name is the same in all instances. Yeah.
So a child doesn't have to inherit everything from the parent?
No, it does inherit it, but it can change how it behaves. Does that make sense? Though technically, and this doesn't apply to Python because it doesn't distinguish between private and public variables. In most languages, only the public methods and public variables are inherited. If you make something private, then it's private to the parent. Does that make sense? But I haven't seen anything in Python that makes that distinction. The overloading is basically, so you have a method that takes 0 arguments, right? And then you have a method with the same name that takes 1 argument and a method with the same name that takes 2 arguments, right? They're overloaded. The compiler can distinguish them because they have different signatures. They have the same name but different signatures. One takes no arguments, one takes 1 argument, one takes 2 arguments, etc. Does that make sense? And each of them can behave a little differently because of the variations of arguments. And a lot of times that's nicer. The user doesn't have to remember 3 different functions. They just need to know 1 function, and they need to know whether they need to pass parameters or not. Does that make sense? So those are, in practice, polymorphism usually is a matter of overriding functions from a parent or overloading function names with different parameters. This is a lot. It's very abstract. I'm not expecting you to necessarily remember it, but I think it's good to go over kind of the theory at some point. Does this make any sense to you guys?
Sort of. Yeah.
Sort of. Yeah, okay. And it's kind of fun when you think about objects. When you're actually trying to design an object-oriented program, I mean, beyond just knowing what the functionality is, it's a matter of how do you group it? How do you arrange it? What kinds of objects do I need? If several objects are doing similar things, do you abstract it out and do some inheritance? You know, there are other ways to do that abstraction too. Uh, I don't think. I think I remember reading that Python doesn't do. Um, there's interfaces. Interfaces not in the sense of form or front end, but interface in the sense of a really lightweight class that has nothing but method signatures. And when you inherit it, you are forced to implement those. I don't think Python has those, so we won't worry about them. All right, I'm going to talk a tiny bit more about what a class, these are what objects in general have. Each class can have a variety of things. They typically have fields, and fields are just variables that describe the class. So if you had a customer has a name. So a field would just be a variable like name. Name, you know, that describes the class. Oh, it does that. And then it can have methods. And methods are just, they're basically just functions inside of classes. So methods are what a class can do. Fields describe what it is. Methods are what it can do. And there are other things that it can have, but we're not going to worry about those. It is possible to put an event in class. We're not going to do that. That's fairly advanced.
So class is the what it's going to do. Fields is the description. Methods is
Right. So the class is. We're going to make one real soon. I think we'll do the dice one in there. A class is basically, say, customer. The fields for that would be like name, customer ID, phone number, email, whatever you want to know about a customer. Those are fields that describe it. What could a customer do, though? I'm trying to think of what.
I should say it's a family. It's
Right.
an overall
They can
family.
buy things.
It's an overall family, and then specific information is it's a customer in the East Coast, customer in the Midwest, customer. Right.
Yeah, they'd all be the. I mean, I think you'd use the same customer. You could put a region in there.
That's what I meant.
Yeah.
And so it's a customer, then you got region fields.
So I'm trying to think of what a customer could do as an action. Yeah.
Are we assuming that this customer object is literally controlled by the customer themselves?
Well, see, I wouldn't assume that necessarily. So I wouldn't. Typically, you don't do a method like where the customer edits customer. You would have a separate object where you allow editing of a customer object or something. Does that make sense? Because part of encapsulation is you want it to be self-contained, and you don't want to get into the paradox of the, what is it, the barber that shaves his own head or cuts his own hair.
Well, but in that case, I would say that one act, like a simple action that a customer object could do, is make a notification when it notices that saved credit card information is sort of looking for. When the card has expired, it puts out a notification. That's a simple thing that
A customer could do that, or
object could
they
do.
could receive the notification too.
Yeah.
Yeah. So there are. I'm sure there are methods. I was just having trouble thinking of them. That might be one. Notification. There could be something where they could add a credit card or something if you had a list of them. So you might have, actually, as part of a customer, you could have a list of credit cards. And the cards could be objects outside of that, but it could have a list of those objects inside. We'll do something like that in a moment, not customers necessarily. Events, as I said, we're going to kind of ignore. Event is something like, so if you think of a button class, on click, right? Or mouse over, or typically you have to map your event to something that the computer understands, but you can create your own events. You could create something that notifies you, say, if a file is opened. You can get notifications of different things. And you can create an event for that. So when the file is open, do this other code. Right? So, but as I said, we're not going to do that much at all. And the other one I'll talk about constructors. You guys know what constructors are? In Python, they're listed as underscore init, which might give you a clue. They initialize.
Initialization is what I was thinking.
Yeah, that is what they are. They're initialization. You might want to initialize certain values in a class. So when you call it up new, that there are certain values that are already preset. That's what an initialization does, basically, or a constructor. And is there anything else? I don't think with Python you don't have to worry about this, but some languages have deconstructors too, where you undo all the values and clear out the memory. C has that in C++ because it doesn't automatically clean up the memory. And if you don't clean up the memory, nobody cleans it up. It's just unavailable. That's what a memory leak is. Is there anything else in there? I am going to talk, and we're going to start writing one here real quick. Getters and setters. And these are also called mutator accessors. All right. And mutators. One of the things about the fields is that generally fields are considered to be, now again, I don't know how Python does this, fields are considered to be private. And you want to get them, or you write a method to let somebody get the value if you want it to be seen by somebody outside the class, right? By another class. Setters allows another class or somebody using the class to change the value. And so accessors are the same as getters, and mutators are the same as the setters. In a lot of languages, so if you guys, anyway, if you do Java or something, you'll have to write gets and sets for different fields. If you take the 172 for me next quarter, there's Microsoft has shortcuts for it, but you could literally just say get : set : and it assumes the method for you. But you have to do that for a variety of fields. So this is a lot of stuff in general, right? And it is very general, and it may not do you a whole lot of good in that general format. But let's write a couple of little simple classes. So I'm going to do file, new file. What do we want to do as our first class? So I said I was thinking of a dice class, which they've got in here, because then we could roll it, and you can see the results. Want to do that one? Mm-hmm. Dice. They do a multi-sided dice where you can enter the actual how many sides the dice has. So if you're doing Dungeons and Dragons, you can have a different, yeah.
D1272.
And then I'll just do. So this has a variable for the amount of dice. So I'm going, the way you write a class is you actually just do class. And that sounds bad. And that's blue. Does that keyword?
No, that just means that
Oh, and you don't have parentheses, so you just have a. All right. So I am going to do this is the constructor, and those should not be dashes. It should be underscores. It has two, and right here it looks like one long one. I'm going to do init self and sides. Self is a very weird thing here. So most languages have what they call class level variables. If you declare them at the class level, they are available to every method in the class. Right? So if you declare them at the top, they're available to every method in the class.
Are there two?
There are two, and it just did it as one line. I hope that works. Oh, and then there should be on the other side too, also. Not dashes, though. Why is it doing them as a single line? As I said, I hope that works. So self is like is how they define class level variables. This drives me nuts, actually, because you have to pass the self down everywhere. So I'm going to say sides, and that means that this is sides as a method or as a variable belongs to the class as a whole. That's what the self is telling you. And it's going to equal sides, which is the sides that is passed in to the constructor. And the initial value of that side, the initial, I'm going to do value. I'm just doing exactly what's in there. Equals 1. So we're going to say that the initial value of the dice is 1. Right? That's just initializing it. If you have a 6-sided dice, it'll be with the 1 up. Right? That's where you start. So that's a constructor with the init. Not every class has to have a constructor, but if you want to initialize things, and when you do like this means that when I call the class, because I have this init, I have to pass in the number of sides. It's required that I pass that in when I initialize the class, which we'll do in a minute. Does that make sense?
So self dot size for size.
Yes. So there's this side is a parameter being passed in. This is the local variable. They do not have to have the same name.
Okay.
All right.
So we do this initializing, we create this initializing function for all classes, or,
So not a class doesn't have to have an initializing function.
but this is no matter what's going to be run when it's created?
Yes.
So
If
we
you
don't
do,
need to call this init.
actually, that's what makes it self-run, right? So when you call the class, this happens automatically.
Okay.
None of the other methods do happen automatically, just this one.
Okay. Second question then. Would self be like an ID or a name or something? The one that we're passing into it?
So I do not know why, as I said, this drives me nuts, and it took me a long time to figure out. If you want to access a class level variable, it doesn't have a way to do that except with self. So I am not entirely sure why self has to be passed into the initialization. But it's the only way that it recognizes that this belongs to the class. This is a parameter being passed in. Self is basically a way of saying it's identified with the class. That being said, I don't know why it's passing into the constructor, but it won't work if it's not. Does that make sense? It's a weird, to me, it's a weird, awkward way to handle this. Why not just have class level variables? I don't know. As I said, Python, I've been playing with it for a couple of years, but this has always driven me a little nuts. Are you looking it up, or are you just?
Sort of. I just looked up in general.
Oh yeah. This is the method for the roll. And again, I'm just doing this, and it just is empty, except it needs self, because otherwise it can't access the local variables. I said it took me a while fighting with these, and I'll show you something that I did you can look at in a bit. So the value, oh, and there's something I need to do up above here too, but I'm going to say it equals rand range, start at 1, and it goes to self sides plus 1. Oh, and that's self dot sides. Okay, the part that I left out outside of the class, I'm going to do from random import rand range. We need rand range for that. And this is no, that looks to be an I. Why is that an I? Okay. So we're just getting a random number. The plus 1 here is because it doesn't include the end, right? If you didn't do a plus 1, you said it's a 6-sided dice.
It would only roll out 5.
It would roll it out to 5. Yeah. So we need to add one more to that. And again, the self is what tells you that it's the local value, right? So what this class is consisting of, basically, it does have 2 fields. It has values and sides. That's what the self identifies. And then it has in the constructor, the initial value, it has the role. And then it's going to have some things that will share the value. And these are the getters and setters. So I'm going to do a def, and I'm going to say get value. And again, I have to do the self if I want to access those class level variables, and there should be a. And I will say basically return self.value. Now you could have just put a return here, but the encapsulation, they usually want a separate method so that you have a total control over how this is accessed. Git could do some variations on this. It could do some checking on it, different things. It doesn't have to be just a return, although typically they are. And then let's do set value. Well, actually, we don't need to do a set value. Yeah, set value. Why are they setting the value? The value's already been. Oh well. I'm not sure this method would ever be used. This allows you to set the dice to whatever you want rather than roll it, I guess. Oops. No smiley face. That's not what I'm looking for. So this one basically self.value equals value. So that it would allow you to set the value manually if you want.
Yeah, range spelled wrong.
I have which spelled right?
Range.
Oh, rand range. I'm missing the D. Thank you. Good eye. I would have noticed it when it failed. Okay, we're essentially done with the class. So we have a couple of fields. We have some methods. And again, the way you define methods isn't that different than what you would do. You might not have done a get and a set in another, in the regular context. You just would have returned this. You might have just, you might have had some way to do it. But the idea of keeping this encapsulated, this dice should be usable however, by whatever program. So let's try to use it. I'm just going to do, let's see how they do it. Did they do it? I just should be able, let's do a main. So we want to call class. I'm not sure I'll do a second one, but let's do, so it equals die, and we have to pass in how many sides? Should we do just a 6-sided one?
Sure.
Okay. And let's do a second die, I guess. Also 6-sided. We can change sides in a moment if we want. And I'm just going to do print die1 get value. Will that space it with just the comma? Let's see if that works. Let's just call main. We'll save this. On the dice class. Although, actually, I maybe want to save. You can save classes as separate files. And then what you would want to do to bring them in is you just import them. Does that make sense?
Yeah.
Let's see if it runs. I don't know. 1-1. That's not good.
Didn't roll.
Oh, I didn't call a roll, did I? Thank you.
No.
So that is right. It just gave me the initial values. Die1 dot roll. And die, oops, I have to do it after I define it. And these need parentheses. Notice that even though it takes self as a parameter, when you call it, you don't have to pass it self. Self is merely an internal thing for the class. So let's save this and then do 3 and 6.
I got an error.
What was your error?
Object hits no parameter. Type error.
Funny, I got 1-1 on my first
Put
roll.
a
And I'm
double
like, oh no, but it
dash
that
on
was
that side.
actually the random numbers I got.
Oh, I see.
Oh no, I broke it. Oh no, it's fine.
I'm going to, for silliness, while, okay, so let's do actually, loop so I can try it more than once. If you wanted to do another value, you just pass a different value in for, and one of the things you could do is you could write a method to ask how many sides do you want your dice to have. I don't think this will distinguish between what's physically possible and not. Don't you have to have even numbered sides? Are there uneven
I mean,
numbered?
if you're just calling a random, then.
Yeah, I mean, it'll just do it, whatever you
Yeah.
give it. So I would say while and these all have to be indented. Um, so I think now, let me run it again. Oh, double equals. I'm just looking to see how random that is. I guess it's pretty good. Interesting, a lot of programming books, one of the very first things they have you program that's any complexity at all is like a craps game. Sure.
I'm trying to do feedback with actually classic.
I just did that so I could roll it more than once. And again, you could have an art before you do this. You could have an input where you say how many sides. You want to do that? And then you do. I don't know if it's the construction of these things. Especially since it behaves after. I have no idea what that. You said you have an error.
Yeah, so that's what I love.
Oh, did you do the import at the top?
Oh, no. Yeah.
Yeah. Invalid syntax. That looks right. Self-sides. So you got def, you have 2 dashes, and then 2 dashes, right? It looks like it's right.
It's too bad right here, no?
Yeah, that
But
looks
the
fine.
color is not.
Well, it looks all right though, def, and then some sides. Why is it hidden in the 11 input range class side, definite self sides? It looks good. Try one more time. I don't know why.
It's a colon missing at the
Why
end.
is that a?
Mm,
You know what?
You
I
have
think
a
I see
space
it.
right
Yeah,
there.
I just saw that too.
yeah.
You have a space after the first 2 dashes.
Oh,
Yeah.
Did you go over
okay.
with the debug from the last time?
What the debug?
Okay.
Very elegant thing.
Oh,
What I did was I simply just did, I just mapped the, you're just doing 2 operations in that one time. So
yeah,
you're only gonna get, like, you're not gonna get each operation because you're doing it so elegantly. Or as Einstein said, it's beware of the elegance of math sometimes. So what
yeah,
I did was I literally did the algorithm from Excel to just go cell -1, cell -2, do the operation, do the adjustment, and then keep going.
yeah. Which was a good, good way to do that.
Yeah.
Let me see what the error is now. Line 30, main. Let's look at your main.
Mhm.
Yeah, die 1 plus die, roll, die 2, die 2, roll.
Yes, that one. Yes.
Oh, you know what? Equals, not plus.
Oh,
See how
right.
you have a plus there? You want it equal.
Equal.
Yeah,
Okay, not fast.
yeah. So this, in
Okay.
other languages too, when you initialize this, like this initializes the class. In other languages, when you initialize the class, you have to use the keyword new because you have to reserve a spot in memory for it, for an object, but you don't have to do this because of the way that it processes line by line. All right, so maybe we should do another different class. Does that make sense? We could do. We started actually with a kind of complicated example. We could have done simpler. Okay, we'll do another one. Yeah. Is it working now?
It's about the size.
All right. So what are now? Side not defined. So self side sides. Where do you have side?
Oh, this one.
Yeah. Phew.
Oh,
Did it work?
I think I missed L and E.
Oh, so it's all little typos.
Mm.
Oh,
S L I E.
I think I saw it.
Sorry.
That's enough. Change that to an I. Okay. So
If you were to add like a variable to the size of a dice, would you add it within under the class before the main and call that separately? I just added it right above when the call the main.
to give the sides.
Yeah.
Yeah, to get like an input for.
Yeah, and one of the things, if you're doing an object, I mean, you could create an object if you wanted for the input, like display or something. But right now, I would probably just do
Just do it right under the while.
right above the while. I would say that let's just say number for number of sides equals int input how many sides. And then instead of putting 6 there, I'd put num. Wouldn't want to do it in a loop unless you wanted every roll to have a different size dice.
That's why I did it a little that way. You different number of dice. But
If you wanted to, I mean, that's what it does is it gives you different.
yes, I did. Okay.
So if I said, what is Dungeons and Dragons dice? 12-sided?
Which one?
20,
There's
20.
20, there are 12
six-sided,
sided,
Four-sided.
four-sided.
10 sided.
I have never. I don't. My daughter plays it a lot. I don't. 12-sided dice. I've seen 12-sided dice, I think.
Yes, there are 12 sided dice.
Okay. No, my daughter does it with some. It's the only time she ever gets up early because she's playing somebody with some people in New Zealand.
If you remember, Melkor as one of the tattoos. If you remember, Melkor is one of the council precursors to it.
Oh, yeah, yeah, exactly.
So let's do a one more class and we'll call it good. One of the things that I'll do, I don't know if I'll do it today. I'm going to do a new file. Is I'll show you how to put together a few classes to work together. As I said, there's a whole classes can relate to each other and they can talk to each other. You want to do a simple one like this? I mean, these are all beyond anything in the assignment, so it's just extra stuff. But well, we talked about an item, right? So let's do like a simple item and then purchase it and then get like a receipt. So we could do several items. So I'm going to just item and sale, and we'll just say receipt. I might need to go get a Kleenex. All of a sudden, I'm just stuffed up. I think it's the construction down the hall. So I'm going to make an item class. Now you can, as I said, you can make these, and I would probably, if I were making them for real, I would do each class as a separate file. And then the way you would bring it in, like if I wanted to bring in the dice, which I don't, but I could just say import, and it would be available, right? As long as I'm in the same, as long as the path is right. Before I do the new one, let's do this. Let's just say import die. And then what I'm going to do is just, I think just do a quick, actually, so I think I have to say die one or something equals die, and we'll just give it the 6 sides. Have to make an instance of it. Now it won't run until I save it, and I have to make sure I save it to where the other one is. I'm going to do file, save as, and I'm going to put it into my Python programs. And I'm going to rename it something else in a moment, I think, but test die. So if I run this, oh, we didn't find die. We should be able to just import the class. Did I name it die? Because I may not have named it that. I didn't save it as a separate file. I have another idea real quickly. Because it's called die class is actually the name of it. Oops. Want to do control. So you can do new file. So now that I saved it as die, it should run. Module is not callable. Why isn't it callable? I know I've done this before. Yours worked? What was the difference?
I don't know. I named it exactly, the import exactly what I named the file.
Right, which I thought I did
Yeah.
also.
Except for I put in die1 equals die with the 6 in it, and it still is, but I added a random, so like.
Oh, you added the random. I wonder if it's the random that it won't do.
Well, I mean, I added the ability for you to choose what.
Oh, you added that, yeah.
They got modules not callable.
Mine's
Right.
fine.
But yours worked.
Yeah.
So that's strange. I don't know. I don't want to spend a lot of time on
Oh,
this.
I didn't put a .py at the end.
Well, either did I. You
Oh,
shouldn't
okay.
have to. Where I was going here is so one of the things this is if you're really interested, this classroom prep. I did some Python classes. Right. So all of this was to handle Python talking to Mongo. And there's some examples of classes here. I was looking to see if it has a so it might be the next one. Mongo client, I think, is my class, right? I think I wrote Mongo client. Maybe not. I'm just trying to look at when I import it because I'm sure that these you should just be able to import. Oh well, let's not spend too much time on that. You just named yours and you copied exactly what I did?
Yeah.
So why is mine not? Test die. It's a Python program. And you just did import die and everything worked.
Well, I think you should.
What? You didn't copy all of it, did you?
I didn't copy anything. It worked like the first time I did it.
So if I did die,
Yeah, try calling the original file. Or
was it
import
die test?
The entire file is working.
Okay. So I didn't find it, but I have to remember what I named it.
It's die class. Isn't it?
Oh, is it die
I
class
think maybe that was it.
with a capital? Let me look. No, lowercase. So that should, let's see if that works. Still has an error. Import die class. Again, I don't want to spend forever on this. Is it test die?
Dice, does it say dice class or does it say die class?
I think, how many sides? Okay, I didn't necessarily want to run that. So I got test die, die class. Was it test die?
I thought test die was the one that you're trying to, that one right there.
Thanks you. And this works.
Yeah.
Weird, because you're not inserting the amount of sides right there.
Because the function, I guess because that calls for you to insert your.
All
I
right.
wrote it into. Like,
Anyway, let's do the other
Oh,
one.
I see.
random number generator.
So the entire thing is being called. I didn't realize that. Okay.
Should though, I mean, should just do it with the die. Let me look at this. Open with, well, let's open with idle. Again, I don't want to spend the whole time. That should work.
It's weird.
You should add the rest of it.
I know, but why? It shouldn't need the rest of it.
It's not that the class is working, it's just that it's calling this and then
Oh,
once
and
you
then
get
it's
to doing
getting
the
the
class.
main function.
Yeah, and then it
and
stops working.
Okay.
So it's not able to get the class out of it still.
So it's not actually calling it.
Yeah, I know, it was just going through the function and
Okay.
doing the other stuff, and then it wasn't able to pull the class out, which is weird.
I will look at this, but you should be able to just import it. That's the idea. What is, I will look. That's not what I was going to do right now, but I'm just looking to see if it has importing it, because I know I've done it before. It might require, let's do, this is the last attempt. Nope, still didn't find it. Okay. Let's not worry about it right now. I'll figure that out. It always bothers me when I didn't do something before, when I made it work before and I can't remember how.
Having that right now.
It might be something that you found it or no. All right, do we have time for this? Let's do an item class. I'm going to do class item. And in the item class, I'm only going to have like the name. So let's do a def and do the init. Those should be not dashes. And we'll do the self. And I'm actually going to bring in two things. I'm going to bring in the name and the price. So I'm going to do like self dot name equals name, and self dot price equals price. Again, they don't have to have the same name. And actually, I'm not sure that I need a whole lot. So let's just do some gets and sets so we can get those values out. Although we could just get them out. We don't necessarily have to do them. So I'm going to do a def get name equals, or not, and we want self. And I'm just going to do return self.name. Make a space for readability. And then I'm going to do a def get price self, and that needs a colon. And then we'll do return self price. Okay, so that's actually going to be my whole item class. You just give it a name and a value, a price, and basically. So let's do, I'm going to, shall we call it cart? I'm going to just call it class cart, lowercase c. Do I want an initialize? I guess we could do an init. I don't know what I want to pass in though. The object, I guess, but mostly we want to just add. Yeah, I was going to ignore quantity. I don't know that we need an init. Let's not do an init and see what happens. Let's just do def add item. I am going to do like a self and then an item. What was it?
You have to do from die import.
Oh, from die import.
Yeah.
That makes sense. And then it worked?
And then it worked.
Okay.
And I took the main off of it and saved another file, so it wasn't just like running that.
Okay, yeah, so from die import.
Yeah.
Okay.
From whatever it's called, import the class.
So I'm trying to think about what I want to name item here. I don't want to call it item necessarily. The reason I don't want it to call it item is that's the name of my class.
Right. Yeah.
So I'm going to do self, what do I want to call this? If I'm being consistent, I should do this. Self items equals an empty thing. Actually, that's what I would want to do in the init, if anything. I'm only going to pass in self, I think. And I'm going to initialize items. I just want a list of items. And what I can do here, because it's initialized, self items dot append product. And then I'm just going to do like display. Well, so I guess display. Make these things up as you go. You should think about them first. I'm going to do itself, well, actually, so display probably wouldn't be in here. Let's just do we want just a total? Display should actually be something else where it displays the list. But let's just do a total. Just make it simple. So we have a list. So for I'm going to do a total up here. And maybe let's call this get total. It's not good to name two things the same. So I'm just going to say total plus equal I dot, and it should, I'm not getting IntelliSense, which worries me, but it should be I dot price. And I'm going to do return price. So did I do something? As I said, it worries me. I have no IntelliSense.
I was aware idle had IntelliSense.
It has some. So I'm going to do a def main. We could do more, but 2 classes is enough for now. What I'm going to do, I'm going to just do this really. So let's do we want to, let's do, I guess, I'll just call it more equals. Yes, I'm going to do a loop. So while more equals y. Wait, my
You have C
I think-
and a double twist.
oh, that's probably what screwed it up.
Also, yeah.
Okay, so then I need to, what I want to do is create an item. So I'm just going to say I'm trying to think of what to name my item. Lowercase item, it is. So we have to pass it a name and a price. So let's do so what I'm going to do name equals input, and I'm just going to say item name. And then I'm going to do price equals input. Actually, should be like float input item price. And then I'm going to just enter here the name price, because those things have to be passed in. And then in the cart, so that creates the item. And then for the cart, I'm going to say, I just need another name for it.
said float instead of float, by the way.
What?
You said float instead of float.
Oh, thank you.
You also need, don't you need to move main or the indentation?
Oh, yes, I do. Thank you.
Yeah. And also, don't you want to return the total and get total as opposed to price?
Yes. You guys have good eyes. So what I want to do, I need to make the cart class. But I need something, actually, it doesn't return anything for this. I think I can do, I'm going to punt. I'm going to say C equals carts. And I don't know that it needs parentheses. Cart dot add item, or C dot add item. And we want to do prod, which is our item. And then, and I think I want to do this outside of the loop. So that it has the scope broader than the loop. And then I'm just going to do more equals input y to continue. Okay, so that's our loop. And then I'm going to just print c dot get total. And that needs parentheses. So it should print the total. We could also do things like I should return for the list and everything. But this was just the idea, and then I think this will be it if it works. We have an item, which is there just to store the item information. And then we have a cart that basically adds the items to a list. And then we're looping through getting the total. You could do a lot more in here. Like you could return the list so that you could display it, you know, like a receipt, all the items with their prices and then the total, which is probably what I would do. But let's see what we got here, if this works at all. So I want to save this as, I'm going to save it as cart. Save. Let's see what happens if I try to run it. Nothing, because why? You know why? I didn't call main, yeah. I can make all the mistakes you guys do. And more. So the item name, I don't know, bread. Get good bread, it's about something like that. Oh, but then it fails. Why? Product. Add item, product, pinned product. Why would that fail? When I did add item, I was passing in product. That should work. It shouldn't matter what I name it. I mean, I could name this product. It shouldn't make any difference. Did I initialize? So let's add product there. I initialize cart up here. So it should be all right. Item. It seemed to be happy with item. Oh, but name and price doesn't. I don't think I knew. So that, yeah, that equals an item, name and price. So I should enter that. That should work.
Can you scroll up?
Yeah. Product is an object. It should work. I'm not sure exactly why. Did you need to see it more?
Still scanning over.
Yeah.
When did you
What was the error message again?
Add item, missing
So-
required positional argument.
So it's like treating the self, but I need the self there. It shouldn't require two items there. So if I do bread again, 434. How do you pass with the self?
Oh, wait, I'm sorry, can you look for that one more time?
Yeah. If I can find my mouse. There it is. I'm wondering, it's like it wants an argument for self.
Well, it's looking for something that you're just calling prod. So where is this prod?
It's
Well, this was prod.
originally?
So why is it still looking for prod then?
Is that what the error is though?
It's mentioning just a prod.
I thought it said product.
It says prod.
No.
So
Down here it says product.
Mhm.
Because I changed it to product. It said prod up above. Because that's what it
I
used.
see, I see.
That's what it
Yeah,
used to be
you did,
named.
you did.
You can't pass self. Let's look at this. I think I remember this is one of the things that drove me nuts. So let's just go Google it. So I'm saying passing parameters to a class method with a self parameter. Yeah, but I want to pass it from outside. I don't want to pass self there. That shouldn't. I don't think so. Let me look. Did I name them differently?
Yeah, you should.
Let's add the parentheses and see if that's the difference.
I did that and it was working for me.
Oh, okay. That might be it. That might be the whole thing. Because it wasn't treating it as a. Okay, so item name. So we'll do bread again. Price. And again, I wish I'm going to kill it. And I killed it so that I'd have some room. So let's do F5 again. Okay, so. Yeah, okay, good. That's much better. So what else do we want to buy at this point? I actually don't know what beer costs anymore. Oh, because it was supposed to be Y. All right, let's do 2 items. I think it works now, except we don't have any error trapping, right? Oh, definitely beer.
All right, where are you getting that price at?
I don't know. When I was young, I could buy a case for that. But that was decades ago. I'm just going to say no. And then it fails. Item is not defined. Why? It was working.
Until it tries to pull the total.
Right.
When you do something that's not Y, it like.
But it doesn't need to know that. For I in items. Oh, you know what? So this is the cart. It doesn't know what items are. Once I do the self dot items. Does that make sense?
Mhm.
I'm just putting garbage in for names.
There we go.
24, 49. So it works, but I had to put the self in front of items here. Again, this is a part. It kind of drove me crazy when I was trying to learn Python. The self variable there, the thing that had to be there for all of the self-identifying. So it worked. Now, that was more of a pain than I had meant it to be. The only point of this, and I'll walk through it, and I'll save this. I'll post this, and I'll post the other thing that we did. Again, this is more than I'm going to ask you to do in most in any assignment. But we have 2 classes here, and so this class is really just a bundle to store the item information. A lot of classes are what they call data classes, just that for just storing data. You know, so you can move it around as a package instead of having to move around a whole bunch of variables. And then the cart basically has a list of items, a list of the items here. And we could do everything you could do with a list here. So I could loop through it to get the total. I could, do whatever I want. You could create methods to add and remove things from the list. All right, so if you wanted to remove a product or something, you could do that. And then you can have another, I just did it in main, but you could have another class that basically, maybe we could return the self dot items. What that would allow you to do is you could go through and loop through them in a display class and show, basically create a receipt. So we could do that at another time if you want. I just wanted to show you the classes can work together. And that, as I said, was much more painful than it should have been. And then we'll do, so I'll do the die class. I'll paste that and I'll put these up onto the blog. Yeah. And then what we'll do next time is we'll talk a little bit more about classes. This weekend I'll try to think of a fun example that, and then practice it so that it works instead of making it up on the fly. Yeah.
Okay, niece, I think I got the outline finally.
Mhm.
Ah. So I'm trying to recreate what I did, like this is like between midnight and 6 a.m. with Mountain Dew, school. And so I'm in a debug mode, so it's like, and so I'm trying to replicate that in the cheat sheet. It's like, but I finally realized what I did, I simply didn't follow their instruction or something, copied the shortcut over what's like, boom, the sky is opened up. So that's why you write a cheat sheet, yes. Yeah. Now I'm just playing around with maker and color stuff, but yeah, I can get the sequence with the TK def and with the G. Yeah, so. And so we should be able to look at the website together and say, hey, you should on your own download brackets, Conzilla, idle, the idle thing, and Python, and then git bash and get home. But they can do that now. They can figure it out.
So that's what my item is. It has like two parts, and a circle has a few parts. So you can contain a list could contain multiple. But so you could, yeah, I think you could do like a draw and then from the list choose which one you want to do. Okay. So I'm just doing the paper. Yeah. Or we could move through the list and draw each one. I don't know. Actually, it should be through the others straight away.
Yeah, so I started to revise, so I brought my carts, I put all my layers and stuff, because it's gonna be cold anyway. So I'll have like 5 or 6 layers to pop in a little roll around.
All right, I'm gonna post these.
Think about it, right, you're gonna have like snow, it's gonna get really cold in the winter with the, shoes, the layers, your pants, 4 to 5 layers.
And stop the video.
Socks.